Okay, so I have some slides here. I don't know if you guys, well, I shared my screen so you can see them, and feel free to add your own notes to this as I go through them. And I just basically put down some different talking points, points of discussion, questions, uh, and but I also want to have it be kind of an open discussion. So we don't have to follow this template at all. If people want to discuss different things, feel free to interject and start talking about it. But in general, so for turn-taking research, I think the main goals I put here are that we want to develop better dialogue systems, whether these are, just spoken dialogue systems or whether they're more interactive kind of situated dialogue agents like robots. That's where I'm coming from. That's my background, is more in human-robot interaction. So that's obviously one reason to pursue turn-taking research. But another one is more on the cognitive science side. We want to maybe understand more about how humans engage in turn-taking and maybe develop computational models of some of these processes. And I'm sure there are other reasons that people are interested in turn-taking research. One observation I've noticed is that it doesn't seem like there are a lot of production systems that take turn-taking very seriously. I haven't noticed too many sophisticated approaches to turn-taking in the industry itself, as opposed to research labs doing prototype systems. So I don't know if we have anybody in here from the industry, but I'd be curious to know if turn-taking is considered a priority at all, or if it's considered more of a kind of a secondary thing where, once they have the NLU and everything and the system can respond appropriately, then they can start worrying about whether it's taking the turn when it should and that kind of stuff. So I guess that's a question for everybody, if they've interacted with any production systems that have sophisticated turn-taking, and whether they've thought that this is a priority for people in the industry.
Hi, my name is Manoush, and I work at Interactions company. So it's an IVA system for enterprise customer service. Mm-hmm. And turn-taking is actually something really essential to our work because it's really important to kind of understand when the customer is kind of finished with what they're saying, or basically like understanding when should we really like stop waiting and create an answer, a response to the customer. So if it is kind of too fast, we're missing what they're saying, and if it is too slow, then maybe it's like a long pause or something, and it's not necessary. So it's really important to find that like sweet spot of like when should we really kind of stop and prompt back to the customer.
Great, thanks. That's really interesting to get that kind of perspective. Does anybody else from the industry have any thoughts about this?
I can. Oops, sorry.
Sure, go ahead.
No, I can jump in. I'm both in academia and industry. So at robotics, of course, turn-taking for the domains we are working with is a very big thing, or it's a very important topic. One example is an interview scenario where the robot is performing a job interview. And you're asking these kind of open questions, and the person answering is sort of starting to answer, maybe thinking a little bit and so on, and it's often actually very unclear when the answer is done. So that's one example, of course, and then in multi-party situation that I talked about in the keynote, and so on. So there it's clear, I would say, that turn-taking is a big issue, and we don't have yet sort of very good solutions, which is partly because it's very hard to come up with general solutions for different domains, because turn-taking looks so differently in different domains. So that's especially if you want to do machine learning models and so on. Often you have to train them on sort of domain-specific data. So that's a problem.
Right.
And also I would just say from experience, when talking to my Google Home device, I actually have a feeling that it has different sort of timeout thresholds, depending on what I have said. So I think there is something being done there. I don't know what, but I am just assuming they are doing something.
Great. That's thanks for that perspective. Ramesh, I believe, had a comment.
Thanks, Felix. So, yeah, that's what Gabriel said is exactly one of the most important things here. But it's also very important at the silicon level because when we think of resource utilization, turn-taking becomes extremely important. Like, for instance, now wake words are kind of a proxy for kind of assigning turns. But as we try to kind of move away and try to, explore creation of, dialogue systems for numerous applications, the systems have to kind of plan turns, as to when to take turn and allocate resources properly. If we have to create, for example, in retail stores, right, for instance, we want to have, a person, like now we have Amazon shoppers or Whole Food shoppers who kind of go, at least in the US, who kind of, we can just order it, and they're off shopping for us in like a few, minutes. And then we can just go to these stores and pick up our items, within an hour. If we want to kind of streamline this process better, kind of a dialogue system, which is kind of interacting, with them and kind of coordinating as to which items, if they are out of order, right? I mean, like some items, when they are out of order, I mean, they don't have those items anymore. Then what's the alternative they want? Now they, send some messages, but if we have dialogue systems there, like spoken systems, that could kind of make it more efficient. But to kind of have these, low resource utilizing dialogue systems, which can basically run off of, very simple button cell batteries with, silicon, the systems clearly need a very, a good turn-taking module. So that's the reason why I think it's going to be one of the reasons why it's going to be extremely useful if you are trying to make these portable dialogue systems. So yeah, I mean that's something that I'm looking at as well.
Thanks. Yeah, those are great points. Are you? I'm sorry, I'm not familiar with your affiliation. Are you from Amazon or?
No, I just finished my PhD at USC ICT. Now I'm at Intel Labs. So.
Oh, okay, cool. Were you working with like David Traum in his group?
No, I was working with David DeWalt and Caliroy, Georgia.
Oh, okay, cool. Yeah, I interned at ICT one summer a couple of years ago, and I worked with David Traum, but I also met Caliroy as well.
Yes, I remember you from there, but I wasn't there. I was in Portland already. So.
Oh, I see. I see. Okay. Any other thoughts about any of these questions? Well, the industry question, that's one. And then another one is, what are just some problems that people are studying or that they want to discuss in this session? Any priorities that people have about turn-taking research?
I would be curious to know what you mean with develop better systems. What exactly the dimension of quality is you were referring to here?
Develop better systems. So coming from my background in human-robot interaction, it's we really want to develop more human-like interactions. So saying something to a robot and then waiting for it to respond, for 3 seconds while it's processing, and then waiting even longer for it to maybe initiate whatever action it's trying to do, really kills the naturalness of the interaction and will change the way that people interact with that agent. So for me, a better system would be more responsive and more fluid. And that was kind of the purpose of my talk at the RoboDial session yesterday. But I'm sure, depending on the application, as some of the people here already mentioned, there might be different priorities that they have for what makes a better system.
No, the point I was trying to get at is sometimes I find that people optimize for fluidity where I think this is just a secondary property. The important part is that good turn-taking supports good conversational grounding, right? And just having just faking fluidity might not be it gets us towards a better experience perhaps, but this experience breaks down if the robot says and then it does something completely wrong because it just faked the based on prosody. So for me, part of turn-taking research, well, I think the underlying thing is incremental processing, right. And turn-taking is just one showcase of it.
That's a really good point. Yeah. Yeah, I have another slide up here about the different computational challenges, and yeah, you brought up some of these. So incrementality is obviously a big one. Kind of, we need incremental systems to enable any kind of fluid turn-taking and like real-time grounding. Then there are these other cues, other features that we can talk about as well, like being able to predict, build up partial understanding as the utterance is unfolding, or in some cases even just generate a full prediction from partial input. Then there are obviously issues of timing as well.
Can I go back and sort of elaborate on one of David's points?
Sure.
And see if you all agree with me. So in turn-taking, people usually think of turn-taking as separate from everything else. And this is like a turn-taking system that controls us, constrains us, we follow the rules. It has nothing to do with anything about content selection or our goals, which is a very convenient approximation for doing research, and I'm guilty also of doing lots of research in that thing. But ultimately, as David says, it's about, the turn-taking has to be done in the service of establishing rapport or establishing dominance or whatever we're trying to do. And I don't know of any work really that's doing that. Or is that just my ignorance?
I wanted to. I talked about our virtual patient at Ohio State earlier this morning, and it has a real need for good turn taking because we want to emulate as natural a doctor-patient interaction as we possibly can, and we're using off-the-shelf speech recognition in our spoken version of it, and so that I think you. Nigel said something about Google, or maybe it was Gabriel, who said something about Google's end of turn detection. So they are doing something, and we used whatever we got out of the system, but it still is pretty simple. So I wanted to try to incorporate some of the semantic understanding that we were already doing, along with some of the turn-taking decision-making as well. Didn't get around to it before I graduated, but but yes, so the need is certainly there. I agree.
I also just want to second what David was bringing up. There's really not, to my knowledge, a framework that supports incremental processing and dialogue that is just openly available, that we can pull down and fit in our systems or fit in a broader dialogue system. Something that might get at some of the problem would be Microsoft Research's platform for situated intelligence, which is at least getting at some of the streaming and aligning all the streaming sources of information. I would throw out the question that, have you used any useful frameworks for incrementality that does real-time processing?
What about ImproTK, David?
Yeah, I was going to suggest this. It's not very, it has gotten a little bit old, so I wouldn't necessarily advertise this. But I mean, at this conference, Thilo Michael presented Retico, which is sort of a Python re-implementation. I've only played with it a little bit, so I can't vouch for how easy it is to set up, but it looks very promising. So I will certainly be checking this out. But I mean, here as in, I think the same thing came up in the dialogue management session. It's difficult to have frameworks for this because this is still very much fundamental research, basic research, and
very difficult.
I think with InfoTK and Retico and similar things, we hit the right level of abstraction, which was very abstract. So basically, all the actual content that was sent around, you had to provide yourself.
For these frameworks, is it working at the sort of the studied timing duration of human conversations? So imagine the incrementality is working at the rate of how humans speak and how they overlap, like at the the 100, 200 millisecond level. That's sort of probably the building blocks, right?
Right, absolutely, yeah. I mean, another thing is in InfoTK we used Sphinx speech recognition, Sphinx 4 running on the device, and this gives you very, very fast hypotheses. They're almost all wrong, unless your domain is very small, but they're very fast. These days you use cloud-based stuff, and it's a little bit slower. Although things seem to be moving back to on-device. I have no experience yet with these like super new models that run on mobile phones, and if it is possible to get it.
I guess the ASR has always been the bottleneck of any incremental system. If you can sort of solve that part, the other parts are not as sensitive, I guess.
Yeah, but
and I mean, of course, ASR has been a bottleneck, not just for incremental processing, but for dialogue systems in general. But the accuracy aspect of it has improved a lot, of course. But the incremental aspect is still a problem.
But I think there's another problem, which is, and I hate this sort of, well, I basically at this stage work on basic research on turn taking and distribution of speech and silence in dialogue or multilog or whatever. And I've noticed for quite a while that there's a sort of a hang up on the SSJ algorithm, which essentially, when you start going outside of a simple question answer, A, B, A, B, A, B, people aren't so much, that sort of turn-taking economy kind of falls down. That sort of idea that everybody's trying to catch the flow or falls down. And you get this people making sort of contributions, and that starts to bring in the whole back channel or whatever you want to call it. And I think there's a definite need for systems which know what to ignore from the VAD, basically, or what they can safely ignore.
Mm-hmm.
In that there's the sort of the foreground conversation, and there are certain types of sounds. And I know that in KTH, and you've been doing lots of work on that sort of multimodal turn-taking models. And I'm wondering, sorry, that's Gabrielle, and I'm wondering if that'll take, you see, because I don't have the maths, unfortunately. I'm wondering if that'll eventually take care of that thing of needing to know what not to respond to, basically.
Yeah, I guess I understand what you mean. That sort of there is certain types of overlap that is sort of. But what do you mean that it's the kind of speech that you could sort of safely ignore? Or
I mean, if you look at a track for a conversation, you're going to have all sorts of contributions by people in overlap or in the clear, which are not necessarily giving much information towards carrying on the task, etc. Because people tend to fill silence, whatever they're up to.
Mm-hmm.
And it's that, and I don't know how much of that can be pulled out. I mean, it could be pulled out by some sort of discourse model, maybe with a language model, but I don't know at the moment how that can be even approached.
No, and I guess, I mean, another typical thing is if you have any corpus of human-human dialogue and you try to sort of make it into turns, the whole thing falls apart because it's very hard to say where a turn starts and ends and so on, and sort of put it into this nice like movie script dialogue. And you have to add a lot of heuristics and stuff to sort of say, okay, we can ignore this part and so on. So I guess that's kind of a related problem, because most dialogue models are based, so when you want to do dialogue management and so on, the fact that you have these turns that are sequentially coming after each other. So when we have, that's something you notice if training like a model to predict turn taking based on human-human dialogue, and you want to, for example, incorporate linguistic features, you have to sort of enforce this these turns that are sort of not naturally there. It's something you have to sort of invent when you process it. But they are important still, because turn taking is affected by these linguistic cues. Like if you ask me a question and I answer your question, the fact of sort of where my turn ends is affected by these pragmatic aspects of dialogue. So I have to sort of force this turn-taking model on it in order to use these cues. And that's something that is really challenging, and maybe an area where it would make sense to try to see sort of what can be ignored, as you say, with all these overlapping speech and so on.
Yeah, those are some great points. I wanted to touch on different cues. So there's been a lot of research on this, both on the from the behavioral psycholinguistic studies on human-human turn taking, and also applying these to computational systems. So all sorts of cues that are used for signaling that you want to yield the turn or hold the turn, or cues to aid in prediction of the ongoing turn. So actually, Gabriel had a good table of this in his talk. I should have just copied that over here, but I think I captured most of the cues here. So I guess I wanted to ask people which of these are the most important. I guess I know that's a loaded question, and there's fierce debate in the field about that, and not always agreement. But which of these cues should we prioritize for dialogue systems, and do we need to use all of them? Like, we know that humans probably use all of these, but can we get away with using just the key ones that matter? What do people think about that?
Well, I'm kind of biased towards processing because my background is in speech processing. And as Gabriel just said, anything that we want to get, like do some kind of text processing, like using semantics, syntax, any type of those features, we are basically limited to the ASR system that we are using. So we need something to convert spoken words to text. And ASR has lots of errors, especially like when people kind of are hesitating or pausing, or there's background noise. So there's all kinds of problems with the ASR. And I also have a question for Gabriel, like from your talk, you talked about like using the fillers as one of the features. So how do you get those, basically those ums and ahs from the ASR?
Yeah, I guess that's it depends on the vendor. Actually, Google don't give these cues at all. They filter them out, which is bad for us if you want to build dialogue system. But I noticed that Microsoft are actually reporting these build pauses in their speech recognition results.
I think.
Yeah, but
Sorry, I think some of that is just an artifact of the way that the models are trained. In some cases, possibly. Of course, I don't know how it's entirely done, but I think
it has been assumed that it's sort of extra stuff that should be removed.
Like, I think some of them are trained on like interview transcripts, like manual transcriptions of interviews, where the transcriptionist will just exclude all of the disfluencies, and so the model necessarily learns to ignore those.
It's like the whole original point of Liz Schreiber's work was to develop an algorithm that could pull them out of transcripts and bring the text back to something, amenable to processing. The whole disfluency system she built was to get to do that. So Yeah, but my other problem with that is the when you talk about ums and ahs, they're not multifunctional because there are different acoustics to each of them. And the basic problem with a lot of face-to-face talk is that by definition, a back channel is both visually and acoustically very difficult to pick out because it's very low frequency. It's just, your mouth is practically closed. You don't have a nice big round mouth or something. So it's lost unless you're talking about a telephonic signal or very well separated sources. So what I was trying to say there is that in all of these features, I think there's a huge question of which of them you can get your hands on realistically in a situation.
Right.
How do you mean get the hands on, or sort of?
I mean, if you're looking, let's say you know that fill pauses are a good indicator of a turn hold or a turn retention. Or you know that a high, an L star H sort of a filled pause and is generally, let's say, surprise. It's an O rather than an The O's you'll be able to get quite easily, even when you're looking at, co-present people. But if they're not co-present, you're going to find it hard to extract that from any sort of microphone track, because if somebody else is talking at the same time, they're gone. So all of your back channels are very hard to pick out. Sorry, I didn't phrase.
I get, yeah.
You know what I mean? But I think there's a huge problem is what you can actually, which features you can actually get from your recordings.
But now you're talking about back channels, I guess, which is different from filled pauses, or sort of, which are not necessary. I mean,
yeah, well, you've got
the turn holding cue of a filled pause is not necessarily very soft. It can be quite loud.
Yeah, but it can very often be used around those areas. Is where you will have somebody else also back channeling. Just at these turn relevant places is where you tend to get a lot of stuff from lots of people.
Right.
But it looks like you're talking about transcripts here and not necessarily about like human conversation and not human machine conversation.
Yeah, exactly. I suppose.
But I mean, even if we're talking about human machine conversation, maybe this suggests. So one question, of course, is what can we do at the present moment? And there, I agree. It makes sense to look at prosody because you run this to open what is it called? Open Smile, and you get a nice incremental stream of data out of it. But maybe this suggests talking to our friends at signal processing more and convincing them that they should actually, the ASR should be giving us this stuff. Because if the question is what cues should we be looking at, then I would, and this goes back to my earlier point, I would still maintain that we mostly need to look at semantics and pragmatics. As Gabriel just said, the turn is over when the contribution is complete. And in irregular cases, you may notice that someone is struggling to completing their contribution, and then you might want to do something. But typically, the most important cue would be syntax and semantics, because you want to project the end, but also you don't want to be back channeling or answering before they're actually have completed their contribution.
I would argue that's not always correct. Like when in a human machine conversations, when people, in an IVR case basically, like when people are asked about what is your phone number, or for phone number we know how many digits, but there are sometimes like some digit sequences we don't know how many digits it is, and people, they do a pause and then we don't know, are they finished or are they not, or there is no basically semantic or syntax cue there. So the only thing we have then is just the acoustic cues.
That's true. That's what makes number sequences an ideal showcase for a system that doesn't do semantics. And this is something that Gabriel built a long time ago, and that worked quite nicely. But the domain was specifically set to avoid any advantage humans would have from predicting semantic completeness. But yeah, if that's your use case, clearly, then you need probably.
My current view on these different queues is that sort of the semantic pragmatic completeness is sort of the skeleton, which forms the sort of, it goes back to Ford and Thompson sort of, where this is the skeleton that sort of provides potential completion points. But actually, if you look at it, there are so many potential completion points, depending on how smart you are. If you're very smart, you can use pragmatics to figure out that you can sort of filter away a lot of these potential completion points because you use the dialogue context and so on. But our systems are not that smart, so you will have a lot of potential completion points in one sentence. And then you need the other queues to sort of filter out these and understand whether it's actually complete or not. So that's a little bit my current take on
I agree with that. Sorry, go ahead.
No, go ahead. Go ahead. I'll follow.
So there's a question about this turn yielding, holding, and prediction, right? Like I think the biosignals and biofeedback was also something that I've read in a few papers where, like the heart rate or, like the EEG spikes, I guess, they tend to show indication as to when someone wants to grab turn, right? I mean, I guess it's there in your next slide or the slide after that where you speak about multimodality. But I think the biosignal should be one of the modalities for sure, right? I mean, we have Fitbits, like as a very simple, like heart rate monitoring system. And I think, like with a lot of, startups coming with the devices which can measure these biosignals, I think those could really prove, like a very important feedback. I mean, those could feed, like into these models which can predict as to when someone wants to grab turn or when someone wants to grab turn.
I'd be careful with that, Ramesh. We tried that quite a while ago with what were Q sensors at the time. And the problem with that signal is it's so slow compared to actual speech events that forming any sort of correlation is very, you get a signal, but there's no obvious kind of correlation between it and the speech event signal. So it's definitely an area. I mean, I'm not sure which biosignals would give you something, but we were basically going on, I can't even remember, the skin response, the galvanic response, and heart rate.
Right. I guess heart rate is probably not so, I mean, heart rate really is, depends on a lot of other cues, but, I guess I'm citing this one study where I forget the authors, I'm sorry about that, but, like they were actually, I mean, the EEG, I believe, signals were measured, and these spikes, they call there's some weird digits there, but these spikes could actually predict as to when someone would grab turns. But yeah, I mean, I think it's one area of which could be really interesting too, because like with a lot of hardware switch, I mean, like people are interested in measuring or getting feedback about their own bodies all the time, and it could be really interesting to kind of include these feedbacks into the model.
Yeah, but the problem is an EEG is not a response you can really pick up on you kind of need electrodes or a cap for the brain. It's not that easy to pick up, but I mean, yes, absolutely. But I was going to say something about what Gabriel said there. And I think there's another problem in this whole turn-taking thing, which is the nature of spoken language. I mean, if you listen to anybody speaking, it's a constant stream of these right-hand added clauses. So even listening to Gabriel there was, and we did this, da, 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 da. And then there's a silence, and you kind of expect him to go on, but you could accept that as being syntactically and semantically complete in itself. And I think it's a two-way thing in that the speaker is also incredibly sensitive to silence and tends to add on a bit if there isn't. So you're caught in this kind of weird little arms race there as well.
That was such a headache with our virtual patient because the patient was slow to respond, and people would then fill the silence, and it would decide that they had finished, and they would be talking over each other. It was terrible. But yes, I know exactly what you mean.
But it's not a bug of human talk. It's a feature. It's how we produce language through our voices rather than on paper.
For sure.
But it's also that we are very good at sort of handling when there is a turn-taking problem. We can very quickly resolve that, and that is something that dialogue system currently are not very good at.
Exactly, but I was just trying to say that, you know, even the end pointing of when you're finished, it's kind of dodgy, because you could in fact be almost triggering somebody to start again.
Right. That's yeah, I agree with that. So that's why I think you need some aspects of the dialogue structure as well, and the whole general pragmatic context. You know, if for example Gabriel is presenting his thoughts, and he comes to a point where there is a you know, a completion point, there, you know, maybe there's a TRP after what he said. It's not necessarily an opportunity for somebody else to grab the turn, because maybe he's still elaborating. We want to give him a chance. There are all these other dynamics at play. So it's not as simple as just, I think, looking at lexical and semantic cues and then determining that his turn is over because it's a point of completion.
Yeah, I
No,
think
but pragmatics involves a lot. So
right.
it really involves a lot of those things.
I think there's value in going back to, for example, a lot of the work by people like Halliday that doesn't really feature on this side of the world, because I specialize in casual talk, or I'm not going to say chat. He has a fantastic example of exactly this, where there's a sentence. It is a sentence of about 150 words, really, which is just what somebody would do to explain a process. There's no real point at which you can say, he's definitely finished or he's definitely going to go on reading it, because it's just blah, 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 and blah, 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 but. There's no embedding. It's not as fine-tuned as written language. And
no, pragmatics would tell you at what point you're happy, and you can risk barging in, right?
Yeah, but again, you're back to that idea that you have something to say and you want to barge in, that there's always this.
Sure, but I mean, if we're talking about ideal dialogue systems, they should also be capable of deciding at some point that it's enough.
Yeah, sorry, it's one of these kind of far-fetched points that, I mean, if we're saying that, let's say a dialogue system is, which I'm very interested in, is instructing or teaching. We want
so
that.
I would take away as a point here that the notion of, it's not always clear that even the speaker knows that they're finished.
Exactly.
And in that sense, there may not be sending cues. But this brings us back to the idea that dialogue should always be a cooperation, and it's not just up to this current speaker to decide when they're done.
But we can also agree to be silent in a way, which I think is
right. That would be sort of the flip side of it. It's also okay for both to be silent. That's maybe not realistic for
no, but I think it's coming in that if you're trying to teach somebody something and their affordances are such that they expect it to be in these little bite-sized pieces, it makes sense to do that, because that's how somebody will understand spoken instruction. But you then have to change your entire turn-taking modality there not to expect responses.
I'd be curious to go beyond speech, thinking about the visual element. And I'd be curious to know how much visual will really help, depending on the mode of interaction, right? So I'm thinking, let's say if you have two humans who want to, or a human and an agent that want to communicate covertly. So not just using speech, maybe instead using body language. So maybe that's just their body pose and gestures and gaze. I think in those scenarios, we need to also think of a turn as not just including speech, but just a visual cue.
And I can just add on that it's not just a visual cue, but if it's a physically situated dialogue, I mean, actions can be a turn. So if you say something, right. I want to buy that one, and I put it on the counter. Clark had a nice paper about this, and I put it on the counter. That's like a dialogue move in a sense. Then it's not like a gesture or sort of a cue, but it's an actual sort of thing that would make you then say your next thing. So actions can of course be sort of turns.
That's sort of grounding by. He had a name for it. That grounding by. It's sort of an implicit grounding.
Yeah, I don't know if it's grounding, but it's.
Yeah, sorry, in the sense that you hand over the package and I put it in my bag. Has essentially.
Oh, you mean like coordination then, right?
Yeah.
It's coordination.
It's in Clark.
Although something that I always found interesting there is that it is still rude not to say something. So if I ask you to pass me the salt and you just slam it in front of my face, that might be a dialogue move, but somehow there's the obligation to say something. Interestingly, so it isn't quite at a par with actual talking.
No, but it can be part of it. So I can say, if I say, do you have this? And I say, sure. And then I start look around and then I find the item and put it on the counter. So sort of these things together forms my turn, sort of.
Yeah, which prompts your thank you. I mean, what's
exactly.
The vocal thing is that here you are.
Yeah, but I don't think it has to be there. So it can be the action itself also. That sort of.
Yeah, no, I was kind of saying that to David, that there wasn't a missing, that you're handing over the thing was the full act, if you like, in the dialogue, and that the thank you was the next act. Sorry, just thinking.
I would actually be expecting a here you go as well.
No, not in my house.
And not just the salt shaker, but I mean this again brings us back to the underlying point is that we want the dialogue to move forward. We don't want turns to be taken. We want the dialogue to move forward in an orderly fashion. And so obviously actions can do this as well.
Yeah, actually we had this in the card game quite a lot. Like if the robot says, I think the zebra is the fastest animal, and then the user just moves the zebra without saying anything. And then they are done with their turn. They expect the robot to say something. So, and again, sometimes there is a speech, but the speech can come before the action or during the action or after the action. So they sort of go together, but it's not very clear exactly how, or so it can look in very different ways.
Sorry, it is another form of co-created or collaborative creation of the ongoing dialogue. That if you were working somewhere where you're forever handing salt over to somebody, you'd stop, and that's perfectly valid as well. But
yeah,
it's a different
sure, of course, especially if you work together and you want to make the dialogue efficient, and you might.
Sure. The usual example there would be the doctor and the assistant. If the doctor asks for some implement, you wouldn't expect an here you go and a thank you all the time while they're cutting someone up.
Because it's at the far extreme of sort of task-based. It needs to be utterly, you can't confuse what they're saying. It needs to be straight up. Although they've found with air traffic controllers, to everybody's cost, tend to have a little bit of chatter in the middle of it all, which is the one situation you'd really expect them to just be code.
It's been some great discussion so far. We're running out of time. I believe we have 7 minutes or so. So I had a few more slides. I had a slide about human models. I don't know if that's something that people want to discuss. You know, to what extent should we be basing our models off of the human data? I'm inclined to think that this is a very useful source of information that's going to inform how, you know, effective turn taking will be with our systems. Although, of course, you know, there is work, I think Ramesh mentioned, using like EEG or biosignals, which obviously humans don't do. But if that's effective, then hey, we should probably use that in our system. Although I'm not sure how practical that would be, given that you need the electrodes hooked up. But in general, there has been a lot of study in you know, conversation analysis, psycholinguistics, you know, corpus analysis, and then, you know, controlled studies that people have done examining, you know, these, in particular, these kinds of cues in which are most relevant for, you know, dialogue prediction. So I was wondering what people think about how familiar are people with this literature, and whether they think that the results of this should be used in systems development.
One question I have in this regard is that if the turn-taking models like the ones that Gabriel presented in the keynote, if they're trained on human-human conversations, which we have lots of, how do they work on human-machine conversations?
That's a great question. And I actually have that here, actually. That's my third point.
Oh, yes. Okay.
Yeah, I mean, I guess in some senses, maybe Gabrielle can answer this better than I can, but I think that in some senses, human dialogue is similar to human computer, but then obviously in other cases, it's not. There are important differences. But, you know, for example, we know from psycholinguistics that people use lexical cues, lexical and syntactic cues, primarily to make dialogue predictions incrementally. There's also evidence that prosody is used, and then you know, in face-to-face conversation, visual signals are also used. And I think those are also used in human-computer and human-robot interaction as well. So I'm inclined to think that training our models on human data should transfer well to human-computer interaction.
Yes, although there's the issue in when it comes to generation, there's always the issue of personal style, and if you learn the average behavior from data, then you might be creating a behavior that is confusing to read. So that's you certainly should be able to interpret all kinds of different styles and different behaviors, but when generating behavior, you might need to select.
And just to add to that there is a problem that we don't have that many speech corpora. We have not big corpora, at least. We have like switchboard and map task and maybe some others, but and these are still quite special. I mean, so it's very hard to train on that and then apply it to, I don't know, an interview or something.
Yeah. And there's the other problem that I think we often forget that a lot of the tasks that people have tried to do as toy problems in dialogue systems and indeed chatbots have been extremely formal tasks, which would often by humans be carried out on a form by filling in a form rather than having a dialogue about it. And there's a huge question of when do you need speech? I mean, apart from the eyes-free, hands-free question, what services or applications are better served by speech? And do they naturally entail more sophisticated social knowledge on the part of the machine? Because I mean, if you're talking to Satnav Sally, it doesn't matter really. how friendly and chatty it is. I mean, it makes it better, but it's a kind of a font problem rather than an actual deep problem on the system. But if you're talking about a medical situation or an education situation where you want to build a relationship, then you really do need something that matches human performance in some way to get the value out of the human interaction. I don't know. Anyway, sorry, I have to go. There's a multi-party on in the next room. Thanks very much for organizing this.
Yeah, thanks for your feedback. Really appreciate that.
I have one question about this thing. I guess we are out of time, but what do you mean by predictions here, Felix? Like, what's? I mean, are you saying about language model like prediction, or what's the prediction that you're?
Yeah, sorry, maybe I talked about this so much like in lab that I just used this convention, but yeah, I mean prediction in the sense of being able to predict an ongoing turn as it's coming in, like incrementally. And there's evidence that humans do this, and that's how they're able to produce such short latencies between turns. Gabriel mentioned this in his keynote that the mode of the between turn gaps is around 200 milliseconds. So in order to do that, it's very likely, at least there's evidence to show that people probably make predictions using a variety of cues. So that's what I mean by prediction.
Oh, cool. Because okay. So I also read like one paper that I just shared in chat, which was contrary to kind of what the common belief is that they say like it's not necessary to predict language, but I mean that's for understanding, not necessarily turn taking. But cool. Thanks for clarifying.
Interesting. Yeah, I know it's a bit of a controversial position. I haven't read this particular paper. But yeah, I know there's kind of two camps. One is that people make predictions, and the other one is that people respond to signals, these turn yielding or turn holding signals. And I'm not so sure that they're mutually exclusive. I think it's possible to do both. But there's definitely ongoing debate in the field about that.
Cool. Thanks.
Yeah. So anyway, it looks like we're out of time, but this has been an amazing discussion. Some of the other groups I've been in have been just, very long kind of pauses in between questions, not really engaging. But I guess because we all study turn taking, we like to keep things smooth and fluid. So
Good one.
Yeah.
Perfect.
Yeah.
Thank you.
Thanks everyone for your feedback. I'm going to stop the session.
Thank you.
Oh, be sure to check
Thanks.
out the links in the chat, Felix, that have been distributed here.
Will
I think since we recorded, that transcript should be saved.
Oh, good.
Okay.